Using EDGECAM, I will show how simple and easy it is to machine this SolidWorks part file. The file is directly loaded into EDGECAM, no translators are used, thus safeguarding the design integrity. Of course, you don't need the native CAD system on your kit. EDGECAM can directly load models from all these systems. The component setup page displays manufacturing information as well as providing the opportunity to realign the model. The model is quickly and easily datumed without the need for translate nor rotate commands. From the ribbon bar, we now select one of the stock functions. Values are added to each offset, creating the final shape of stock. EDGECAM allows you to insert secondary solid models, which can represent the stock also. In a similar way, a vise is now added to the part using the fixture manager. The user simply selects the desired vise, orientating and setting the part stick out. The library comes as standard in EDGECAM. The machine tool or post-processor is now selected. In this case I will choose a HAS machine tool. An array of machines are available as standard in EDGECAM, and moreover you can create your own post-processors free of charge using EDGECAM Code Wizard. A toolkit is selected which allows automatic creation of tooling and setup sheets. The machine tool model is loaded, which is used during toolpath simulation and also aids the programmer engaging over travel limits. Feature Finder now identifies the machinable attributes on the part. Pictures and dialogues are used throughout EDGECAM, enabling the user to fully understand the influence of each function. All features are fully associative and are displayed within the feature window. Features can be rendered for better visualization. EDGECAM offers three styles of manufacturing: automatic, semi-automatic and manual. In this example I'll use automatic. I'll now launch Planning Board. As the name suggests, it's at this stage that the user plans the order of machining commands. Unnecessary processes can be deleted from the board, such as this spot drill command. Furthermore, a process can be reordered by using drag and drop. We now apply the planning board. EDGECAM goes to work, executing predetermined machining strategies on each feature. Now you can see why it's called automatic machining. In a very short period of time, the CAM instructions are created. Usually these instructions are created manually, so imagine the time saving being produced by this method. Furthermore, an inexperienced programmer can quickly learn how to machine the part. It's now time for the all-important machine simulation. Here the user scrutinizes the toolpath, but also checks that there are zero collisions. The machine tool model is also checked for possible collisions. The list of CAM instructions are displayed on the left hand side so the user can understand which cycle is at work. Here we can pause the playback, and by selecting the instruction further down the list we can effectively fast forward the playback. The CNC program is now generated. This program would have taken substantially longer to produce had we not used EDGECAM. In normal circumstances our task is complete. However, imagine now that at this late stage the designer informs you of a modification. Do you have to delete all the toolpaths and begin again? Not with EDGECAM. You simply use the reload facility, where the original model is now exchanged for the modified model. As the alteration affects the features, they will display in bold, thus drawing the user's attention. Notice that one feature is marked as orphaned. Specifically, the PCD with tapped holes has been replaced by plain holes. Let's see how EDGECAM copes with this situation. The CAM instructions are regenerated, seamlessly updating the toolpaths to the new shape of the model. However, as EDGECAM reaches the drill and tapped holes, it warns the user that the CAD features are missing. Thus, I will delete the offending CAM instructions. So how can we machine the new PCD of holes? In this instance we can use semi-automatic machining by using the machine features command. Here we can simply elect to either rough or finish, or both, features by individually picking. Therefore, I will pick the hole feature. Notice how the CAM instructions are automatically created on the CAM instruction window. All our CAM instructions can be edited. The user must feel comfortable with the machining methods. Simply double-clicking on a CAM command will display the dialog box. Here we see the roughing cycle using EDGECAM's waveform pattern. Next we see a profiling cycle. Again, the dialog uses pictures to portray the influence of each function. Using such visual aids accelerates the user's knowledge of the software. In practical terms, our work is only halfway done. How about the underside of the part, or its second end? There are features to be machined on the underside, plus the stock shape needs to be transferred to the second end. Well, we simply repeat the steps previously mentioned. Select Setup. This time I will choose a different machine tool post-processor. Moreover, I shall select the bottom datum, or CPL, as a verse to the top, which was what we used on the first side. And I'll elect to switch off the vice, preferring to use a different vice for the second end. The new machine tool is introduced and the part is rotated 180 degrees. Using the same fixture manager, a new vice is introduced. Once again, Feature Finder is launched, this time seeking features on the bottom datum CPL. Flat faces and pockets are stated. The features will again appear in the window. Using the semi-automatic method, the flat face is now rough machined. As EDGECAM has already updated the stock, and the toolpath is stock aware, we are guaranteed the most economical toolpath. You will notice how EDGECAM now creates more automatic CAM instructions in the window. Remember, the CAM data can and will be edited later. Observe the CAM instructions. By default, an 80mm diameter tool has been selected and a lace pattern used during the roughing cycle. However, by double-clicking the CAM instruction, it's easy to change this command. Here we see the full extent of the EDGECAM tool store, and a 30mm face mill is selected instead. The lace pattern is now updated, taking into consideration the smaller diameter tool. The roughing cycle is now switched to a waveform pattern. This promotes high-speed machining strategy. The feed and speed and depth of cut are all increased significantly, thus reducing cycle time and thus boosting productivity. A racetrack pattern is produced. The toolpaths are again checked in the simulator, where the user requests to view only the second-hand machining toolpath. Thanks for viewing this presentation of EDGECAM Solid Machinist for milling.